In our early video, we showed how we were able to add an SSD to a disk drive, an existing disk drive in the system by first converting it to to a fuse drive and then adding the SSD to that. Now what we're going to show here is how to do the reverse, take off an SSD and actually replace it with another SSD while the system is running. So this is a continuance of the last video we did, so you will see that we've settled in at around 3K statements executed per second. There's obviously some oddities going here with the display, but essentially we're sitting pretty much up at the top end range here of what we've been able to see with this SSD. Now I'm just going to replace it with another SSD of similar performance, because in this case we're simulating what happens if we want to replace an SSD we feel is starting to maybe wear out. So the SSD we're going to replace in this case is the drive 1. And drive 1, if you recall from our earlier video on how to accelerate MySQL, is basically the SanDisk device, and then we have another device here we decided we're going to swap it out with as well. Now you could choose to leave the SSD off altogether, of course, if you want to repurpose that SSD for something else, but for the sake of this exercise we're going to show you the whole conversion. So the last thing we did was to convert the drive to a tiered drive. We're now going to undo that. We're going to now say convert back to single. To convert to single, what we're going to have to do is migrate all those pages off the SSD back to the hard drive. So that's what this first process is going to do. So we're going to end up with a situation here where we're going to see, and it's just beginning to start here, we're going to see the traffic return to the hard drive. So as you can see, we're migrating off. The performance is going to drop down as we expect because we're now removing the SSD. And this is going to continue now. We're at 9% right now. It's going to continue till it's showing here 1,000 or so pages. And if you remember, in Fuse Drive, a page is a 4 megabyte block or region that we manage in the virtualization or the virtual disk space, and it's going to be relocating that many pages times 4 megabytes. So we continue to do that until we get the drive fully migrated off. So we've now completed the conversion. As you can see from this time scale here from when we started, that's about 5 to 6 minutes it took to migrate the active database portion of the database, certainly, off the fast tier. It's now all back on the slow tier. And if we look at the list again, we're going to see that we're now back in the state we're in before. Now I'm going to, in this case, create another V drive now from our other disk drive, which is drive 3, because I now would like to go ahead and add that disk drive as my SSD. Remember, the scenario here we're kind of walking through is replacing a failed SSD or something that's certainly not performing as expected. So now we have that. We should find there's another V drive now in the system. Here it is for drive 3, which is V drive 2. Let's go back to my earlier command, convert to tiered, this time using V drive 2. The answer is of course yes, and off we go. And now you can see again, pretty quick process. It's now reconfigured itself. We resynchronize on here, and now we're back to tiered mode, where we're going to start again improving the performance, but this time with the new SSD. Now note, in all this process again, we have not stopped our running test or our exerciser, HammerDB in this case, which has been slowly but surely continuing to hammer away on the database. Okay, so we've left it a little while longer now from when we first started this exercise, and just checking back in so we can just verify that we're now running the database again back at the full performance level that we had it before, which was around the 3K or showing here the raw 4K IOPS for raw devices here, or around the 3,000 SQL statements executed per second over here on the workbench.